friends. Now let us consider, let us discuss about the measurement of three-phase power using two wattmeter method in a star-connected leading power factor, that is a capacitive load. Consider the capacitive load that has been connected across three phases, R phase, Y phase, B phase. Let the wattmeter 1 be connected across R phase and the wattmeter 2 connected across Y phase. The current coil of wattmeter 1 is connected across R phase and the current coil across current coil of wattmeter 2 is connected across Y phase. The voltage of wattmeter 1, the voltage coil of wattmeter 1 is connected across R and B phase, and the voltage coil of second wattmeter is connected across R and Y and B phase. The capacitive load is being connected across these three phases. The voltage, that is the since it is a balanced capacitive load, the phase impedance, the magnitude of this phase impedance is same, and also the angle, the phase angle phi is also same. That is the IR. This IR, IB represents the line current across R phase, Y phase and B phase, and the line voltage. Here we can observe two types of line voltages. One is line voltage, another one is phase voltage. That is here two type. We can I repeat, here we can see two levels of voltage. That is one is line voltage, another one is phase voltage. Line voltage is between the two lines, that is here similarly VRB, the voltage between R and B, VBR, the voltage between B and VBY, the voltage between B and Y, the next VYB, the voltage between B and Y. Similarly, the phase voltages between R and N, the N is the neutral point, is nothing but VRN. Similarly, the phase voltage VYN across Y and VBN across B, and also the phase current IRN in R phase and IYN in Y phase and IBN in Z phase. Now across, this is the construction as shown in the circuit. Now the wattmeter readings, that is the readings across these two wattmeters, W1 and W2, is nothing but the readings across wattmeter 1. The current is I, that is the line current is IR, and the line voltage is VBR, and the VRB, and the wattmeter 2, the line current is IY and the voltage is VYB. Therefore, we know that the power consumed across wattmeter 1 is V into I into cos of phi. Here line voltage VRB into line current IR into cos of angle between line voltage into line voltage and line current, that is VRB angle IR. Similarly, these angles VRB and IR and VYB and IY, that is the angle between the line voltage and the line current, can be measured using the phasor diagram. This is the phasor diagram. Here the VYN lags VRN by an angle 120 degree, VBN leads VRN by an angle 120 degree. That is, as we know, the phasor representation, VRB is VRN minus VBN, VYB is VYN minus VBN, VBR is nothing but the phase voltage of B minus the phase voltage of R. As we know, in a capacitive load, the current leads the voltage by an angle phi, that is the current leads voltage by an angle phi. From this concept, VRB, I get VRN minus, that is VBN is here, I take opposite, V minus V by N. VRB, I get the result, that is the parallelogram, through the parallelogram law of resultant, I get VRB in this direction at an angle 30 degree from VRN. Similarly here, minus VBN, VYN, I get the resultant, that is resultant as VYB. That is VYB as the resultant is the angle 30 degree here. Then angle between line voltage and the line current, that is VRB and VRN, is 30 plus phi, whereas here it is 30 minus phi. That is, therefore W1 is equals to VLIL into cos of 30 plus phi, and W2 is VLIL cos of 30 minus phi. Adding equation 1 and 2, we get VLIL cos of 30 plus phi, cos of 30 minus phi, cos A plus cos B. Have formula 2 cos of A plus B into cos of A minus B. By further simplification, we get W1 plus W2 is root 3 VLIL cos phi. That is, the power is that total power is the power consumed by wattmeter 1 and power consumed by wattmeter 2. Similarly, if we subtract equation 2 minus equation 1, that is the 1 minus 2, that is W1 minus W2, VL IL cos A minus, this is in the form of cos A minus cos B. We have cos A minus cos B is nothing but 2 sin of A plus B by 2 into sin of B minus A by 2. That time if you substitute the further simplification, W1 minus W2 will get minus VL IL sin phi. Equation 4 divided by equation 3, if I do that, I get phi is tan inverse of minus root 3 W1 minus W2 divided by W1 plus 2. This is on further simplification. This form of simplification, the negative sign indicates that power factor of a capacitor load is leading. If suppose if this capacitor, if there was no negative sign, if there was a positive, then the circuit was lagging circuit, that is inductive circuit. Therefore the power factor of the load is nothing but cos phi. Thank you.